Hello everyone, this is Dr. Saeed Falafini from Cal Poly Pomona. In this video, I'm going to talk about preliminary system design. As you can see here, we show the life cycle of the system. The preliminary design is the second phase of the life cycle. We already have talked about conceptual design, which is the first phase. And in this video, I'm going to go into a little more detail of preliminary design, which is the second phase of the life cycle. So conceptual design, our first phase, and preliminary design, our second phase, are pretty much the same. The main difference is that preliminary design, we go into more detail of what we already have done in conceptual design. So both conceptual design and preliminary design try to extract the requirements and expectations from the system. They try to find the functions that should be performed in the system so that we can achieve the objectives, and they also try to design or to come up with the idea of what should be the components of the system that are going to perform those functions and as a result cause the system to achieve its objective. So as I said, both preliminary design and conceptual design are pretty much trying to do similar things, but in conceptual design it's high level, system level. In preliminary design we try to go in a little more into the detail of the design. As we have discussed before, design phase is one of the most important phases of the life cycle of the system. In a recent study that was done by NASA, they have looked at the cost of their projects, and they have realized that those projects that spend only about 2-3% of total cost of the project on the design phase, and as a result didn't pay much attention to the design phase, have experienced about 80 to 200% cost overruns. On the other hand, those projects that have spent about 8 to 15% of total life cycle cost on the design phase, they have experienced something between 0 to 50% cost overruns. So this is some data from actual projects that again emphasizes the importance of design phase and the fact that projects need to spend enough time and money during the design phase so that they can plan for the whole life cycle of the project. So in this graph, again, we try to emphasize the importance of the design phase. So as you can see here, these numbers on the horizontal axis basically shows that by the end of conceptual design, we spend about 8% of the total life cycle cost. So as we try to wrap up and finish the whole design phase, we spend something about 15 to 20% of the total life cycle cost. Most of the cost of the project is spent later during the production and test, utilization and maintenance of the project. But during the design phase, it's mainly between 15 to 20% of the total life cycle cost. So it's not really that much. However, during the design phase, based on the decisions that we make, we commit ourselves to about 85% of the cost of the project that will be spent later on. So in other words, during the design phase, we decide on how we are going to produce our system, what materials we are going to use, what technologies we are going to use, what service or what type of service we are going to provide during the maintenance phase, how we are going to deal with the disposal. All these decisions are made during the design phase. And that's basically what these numbers mean here, that we are going to commit ourselves to about 85% of the life cycle cost that will be incurred later on during the life cycle, and that commitment happens during the design phase. And one other important aspects of this chart is that during the design phase, since it's early in the life cycle of the system, if we find the need to change, it's really not that much costly to implement those changes. But as we go through the end of the design, as we go through production and test and utilization, if we see the need for change because we have not paid much attention to the requirement of customers, so if we see the need for change at those stages, then the cost of implementing those changes would be much higher as opposed to what we may face early in the life cycle of the project. And again, this graph emphasizes the importance of the design phase in the life cycle of the project and the decisions that are made in this phase. So similar to conceptual design, the very first thing that we are going to focus on during the preliminary design phase is trying to get a very good understanding of the requirements of customer, voice of the customer, expectations from the system, what are the objectives of the system. We also try to get a good understanding of the constraints that we may face. So by constraints, I mean the limitations that may prevent you from creating the system that you are planning to create. And if there are such constraints, for example, budget limitation, time limitation, technology limitations, if there are such constraints, is there any way to work around those constraints? So the very first step in preliminary design phase, similar to conceptual design phase, again, is to try to make sure we get a good detailed understanding of the requirements of the customers, and there are different ways to be able to do that. We are going to take a look at those methods. Usually, to find a good understanding of the requirements of the system, expectations from the system, the most traditional method is to sit down with the customers and try to interview your customers and try to understand them and see what they want from the system, what they want from you, what they want you to accomplish for them. They usually have some documents, and it makes sense also to review and read those documents. Sometimes you may provide some surveys or questions to your customer to be able to get a better understanding of what they need. The other method that has been used also sometimes is what we call a group elicitation technique. In this method, you sit down with a group of stakeholders or people from customer side and try to brainstorm with them, and maybe even have some workshop to try to explain to them what you're trying to do and how they can help you to get a better understanding of the requirements of the system. So in this method, you usually, as I said, sit with a group of stakeholders or representatives from the customer, and it's more like an open discussion, brainstorming type of discussion to finally understand what they expect from you. The other method is contextual techniques, where it's not really easy to understand the expectations from the system or the customer wants from you by just interviewing the customer. So in this scenarios, it's better to spend some time really with the customer and in the context in which they want you to create the system, to be able to understand really what they want. So sometimes, especially in the projects that have some social components, this technique may be used. So you may need to spend some time with your customers to be able to get a better understanding of what they expect from you. So we can put our requirements that we get from the customer, the expectations from the system that we get from our customers, into different categories. If we go back to the bike rental system that we have worked on during our labs, some of the requirements that we specified for this system are falling in the category of performance requirements. So these are the requirements that basically say once this system is up and running, what do you expect from this system? For example, if the mayor of LA wants to build a bike rental system in LA, so what would be some performance requirements? And as I said, what do you expect from this system when it's up and running? A couple of those requirements can be, we want 95% of our customers, when they get to a bike rental station, they find a bike. So 95% of customers, at least 95% should find a bike when they get to a station. Some other performance requirements is that from every point in downtown, we should be able to find a station by 15 minutes walking distance or within 15 minutes walking distance. Or other things can be, we want the chance of accidents using the bikes in this bike rental system to be close to zero. So these are all performance requirements, expectations from the system when it's up and running. This is how well we want our system to perform. However, also let's assume that mayor of city of LA tells you that we have some collaboration with Department of Transportation, and we also want to collect some data on our customers. So we want to collect data on how many bikes are rented out every day and for how long our customers rent the bikes. So the system that you design should be able to collect this data and save them in a database and record them in every day. If there is such requirements, that's more like a function that you want your system to perform. And such requirements goes into the category of functional requirements. Also, imagine that the mayor of city of LA also tells you that once we collect this data, we want to be able to automatically transfer to those data to Department of Transportation, and they should be able to get this data and integrate with the system that they have. Because they are planning on number of police cars that they're going to send out in every day. So they want to see how our system can reduce traffic and if they need to make any adjustment. So this data that you collect on how many bikes are rented out and for how long should be automatically transferred into Department of Transportation. They should be able to get this data. So for this to happen, you may need to make sure that your data is transferred in a specific format such that the database that Department of Transportation has can automatically get this data and integrate it with their own. So if that requirement is also there, if you have to make sure the data that you send can be integrated with the data of Department of Transportation, you have to make sure that you record this data and send it in a specific format. And if that happens, those are mainly in the category of design requirements. So which basically tell you, as you're designing your system, make sure this data is saved and is transferred in that specific format. So as we try to extract the requirements from the customers, we can potentially put them in these categories. So a couple of things about the requirements that we have to really pay attention to. So we want our requirements to be as clear as possible, as complete as possible, as precise and concise as possible. So in the next couple of slides, we are going to go into a couple of specifications or expectations that we need from you as you try to collect and extract the requirements from the customers. So our requirements should be necessary. So we want to make sure our system has some features that are necessary and are expected from the customer. So they should be feasible. So we have to be able to achieve those requirements technologically. So we want our requirements to be correct and concise. So they have to be simply stated and everyone should be able to understand those. We don't want our requirements to be ambiguous, and we want also them to be complete. So if there is, make sure as you explain your requirements and as you document your requirements, you try to document them completely and with all the specifications that is needed for someone else to be able to get that requirements and go into the design phase. We want our requirements to be consistent with each other. So you don't want you to have two requirements that try to that are opposite of each other. So make sure all of your requirements are consistent with each other. Your requirements should be verifiable, meaning that you later, as you go through the life cycle of the system, you have to be able to verify and validate them. For example, if you just say that I want this, going back to the bike rental example, if you just say that I want the bike rental system to be available. So what does that really mean? How you are going to measure availability of this system? But if you mention explicitly that I want every person to find a bike at the bike rental station 95% of the time when they get to the station, that shows the level of availability that you want the system to have. 95% availability, not 50% availability. And that 95% is something that can be verified later on through the methods that we have for the test of the system. But if you just say, I want my system to be available, anything can be considered as available, even 50% availability or 95% availability. So another important feature of the requirements is that they should be traceable. As you go through the design phase, you want to make sure that you can trace your requirements and make sure they have been implemented and they are going to be achieved. The requirements should be able to be allocated, especially if they are functional requirements, like the example that I just gave you. We want to collect some data in the bike rental system. We want to make sure these requirements can be allocated to a specific component in the system that is going to be in charge of performing that functional requirement. Another very important feature that we have talked about in class many times is that we want our requirements to be design independent. So you should not say anything about how you are going to make that requirement to happen as you try to document your requirements. So all I want to say is that I want 95% availability of the bikes when a person or a customer gets to the station. But I'm not going to say things like, I want 100 bikes per station. That's a design decision. My requirements is 95% availability. We need 100 bikes per station. That's a design decision. So you have to make sure to differentiate between these two and don't mix them. And don't put something that is design related as a requirement. So make sure you don't repeat requirements. Redundancy is not needed. As you try to document requirements, you try to use some standard terms. For example, this system shall be available 95% of the time. So those terms are usually used. Try to assign a unique identifier to your requirements. That's helpful because that helps you to track those requirements throughout the life cycle of the system. And try also not to use any terms that gives your designer the possibility of not implementing those requirements. For example, the system may be available 95% of the time. No, try not to use any of those terms. You have to be very specific, very to the point, very concise and precise as you specify your requirements. Make sure that all the stakeholders and main customer representatives acknowledge the requirements that you have listed, and everyone has agreed upon those requirements, that these are expectations from the system. Again, make sure those expectations are implementation, or those requirements are implementation free, design free. So you want to say that okay, as we try to collect data in the bike rental system, we try to send them to the Department of Transportation, and we have to make sure this data can be easily integrated to their system. That's your requirements, but you don't want to mention anything that we are going to use that software or this software. Design independent, implementation free. Just make sure to specify the requirements. And one other important feature also is that you want to prioritize your requirements. And this is important because a lot of the times we have a long list of requirements and expectations from the system, but we may not have limited time and budget. But if you prioritize your requirements, you put more focus on those that have high priority. And if you have any time or budget limitation, you drop those that don't have much priority.